Why do we use simulation? Why we would like to have simulation tools and virtual collaboration environment? Because in modern manufacturing system, we need tools to support our decision in terms of investment we would like to make in order to know how to face our customer needs. Then, the more the system gets complex, the more we need tools to understand its behavior. Last but not least, we have to show to our customers something we have not already prepared for them, something we have not built yet, and we have to sell it. So more and more for system integrators, the capability to demonstrate, to show to the customer what they are going to buy, it's really important. So when do we use those simulation tools? Because there are several phases in the life cycle of factory of an offer. And who is there when we are using them? Simulation is, by its basic concept, something on multi-level and multi-user, because we can use it when we don't have nothing. We are on a greenfield. And so we can discuss in terms of management investors, and we may need something to show them. We use an advanced design, and then the technical people kicks in, because they have to further understand how the system is going to work. We can use it in continuous improvement. We can use it in reconfiguration of what we already have. So far for simulation. And now lately, new technologies are popping up. We have new developing environments that provide us with the capability to distribute our simulation system. We have multi-touch technology. The web is faster and more distributed than ever. So what did we do at S.r.l? We mixed them. And so we tried to mix all the characteristics of the simulation environment. We tried to take advantage of all the technology we already have. And we developed, I never know where to point this thing. Over there. Yep. No, too much. Okay. I'm sorry, I spoiled the surprise. So we developed simulation tools that is meant to be multi-level, so that both the management and technical staff can use it. We made a development system that is multi-user, so that most of the people can work together on a multi-touch table, but also technical staff across the world can concurrently, in real time, analyze the same layout. So it's distributed, and it has multiple purposes, because it is so simple that it can be used in the offering phase, but it can get complex in order to get deep understanding of the system. So basically, you already see that. We will demonstrate this evening a multi-touch table over there, but don't worry, it is projected here, so you don't have to stand up. But it also works for technicians on a standard system, and many clients can be connected to the same server. What are we going to demonstrate? We are going to demonstrate an EV carpentry scenario, because one of our customers deals with that. The EV carpentry, when you want to build a skyscraper, an hospital, or whatever, you get a lot of pieces to be connected together. And they are H-shaped iron bars. And you have to cut them. You have to drill them. You have to make them so that you have a set of Lego blocks and your workers can assemble it. So those people, they sell lines. You want to create a new skyscraper, then you have to buy a line. And when you have different offers, the layout proposal are key elements for the customer in order to decide if he wants your line or not. The performances of your line are key important factor in order to evaluate if to buy or not. So, I would also like to draw your attention to another fact. Up to now, you have seen a PowerPoint presentation, and now you're going to be a live demo. So, well, before that, of course, we get money from somebody, and we get most of our funds from the European framework and the KTI. I should have not forgot about that. But then, let's go on. We don't go on. Let's go on. Oops. It's a live demo, so something may happen. This is just a joke, but remember that it's live. Nothing is registered. You see, everything is real time and it's working as you see that. Okay? So I move over there. You don't have to, because, well, if you would like, then you can move as well to touch the multi-touch. But if you don't want to, Then over there, you see the multi-touch. We have a lead camera over there. And here we will have the technician client so that we can interact with the user on the multi-touch table, and then it will be a remote user over there. So you can go on. What is he doing? Now I'm reaching the multi-touch, and we are looking for an existing layout. It's a 3D environment. We would like to make a simulation of an order that our customer has. Please go on. Underlying this 3D environment, there is a discrete event simulation engine. So we are a couple of managers. We know nothing about simulation. So we simply interact with touch. We don't even have mouse. We don't have to code, whatever. It's a really simple way to understand. You can run it. So you can get immediate understanding of the resources, of their saturation, or whatever. Whoop. You should be a bit more tense, but okay. So it's really easy to understand what's going on and what our system performance is. Now when the simulation will run to an end, we will be given a result. The simulation took longer than expected, but then it's a live demo. I should have prepared a longer speech, but I don't want to bother you. You can tell what the line does. Okay, I just forgot about it. This line is an EV Carpenter line I've been discussing before. So we are just processing a standard order of the line. Oh, here it is. So, thank you. My colleague manager showed me what are the main results of the simulation model. And so here I see that one of the machines, Combinata 15, that deals with two different operations, is quite a lot saturated. And we know that this order has very few drilling operations. So we would like to know what will happen to the line if we create something new, if we duplicate some of the functions in order to lower the usage of some machines to prepare them for more complicated order. So we can close this report. And we open up, in a really simple way, we start adding new machine because we are manager. We know the machine, we actually don't know about times or whatever, and we are trying to push things in. So we drag and drop things. And I move it. Okay. Stop the camera, thank you. And move it here. Then it's fine for me. You can add the second machine. So we are creating a new layout really easily. It can be done with the customer because they know what they want, and we can help them to this new layout developing. Okay, would you like to finish or do we pass it? Because we can pass it? Okay, now we would like, okay, you don't see his screen because it's projected down there, but you see in real time what we are doing. And as we are not technicians, we cannot set up the model because we know nothing about discrete event simulation. We know nothing about mid-time to failures or whatever. We know nothing about average consumption of the machine or whatever. So we finish up the layout, we tell him something, and then we tell him, okay, please finish off the models. And we are using it at a very high level, and he is using it at a lower level, a technical level. So please finish the model for us. And we can either watch his screen, and you can find it down there, what he's doing. It's a more complicated interface, of course, because it's dealing with more parameters. But we can also follow what he is doing. Okay, he's connecting machines, giving times or whatever. By the way, you may have noticed that we also have imported a base DXF 2D layout, so that it's quite easy for us to create a 2D representation of the factory. Okay, we can still, since it is actually distributed, we can go on talking about the system, moving things, because the two instances do not lock one another out. They prevent errors, but still you can work on it. Okay? It's finishing the last connections, and I think everything is okay now. No? We're missing one of the last connection. You should really look on it. Okay, can we run the simulation now? Okay, nice. Now we will rerun the simulation with the same, you see the model has been changed, its connection, and we run it in background so it's faster. Okay, here we have the results. Can you also take out the last report? And you will see that the saturation of the resource we meant has changed. So if we have another order with more drilling, we will get a more flexible plant. One last thing I would like to tell you is that this approach has been validated with this company, with our partner in this development. So this is actually mirroring a real situation. Okay, thank you very much for your time, and I think we can finish here. Okay, thank you.